with you, and in this video we're going to be looking at solving one-step quadratic and cubic equations. So we've been working with squares and square roots. We started out by looking at perfect squares and perfect roots, and then we took some time to look at estimating to the nearest integer squares and square roots and cube roots, that is. All right, and in this video we're going to look at solving these equations. Now, quadratic equation is an equation that has this exponent of 2 as its largest exponent. We often call it a degree 2 equation. And in order to solve these one-step quadratic equations, we will take the square root, because square root and squaring, square rooting and squaring are what we call inverse or opposite operations. Okay, over here we have cubic equations. You'll notice instead of a 2 we have a 3, so this is a degree 3 equation where the highest exponent is a 3. Again, we're just doing very simple one step. Quadratic and cubic equations, they can get much more complicated, but we'll save that for another day. And to solve a cubic equation, you guessed it, we're going to take the cube root, because cube rooting and cubing are also inverse operations. All right, so just a quick reminder of what solving an equation is. I've got it written here in red. Solving an equation is finding the value of the variable that makes the equation true. All right, every equation has an equal sign in the middle. An equation can be true or it can be false. A true equation is when the left side actually equals the right side. A false equation would be when they were not actually equal. All right, but they are equal. We're in good shape. Here we go. X squared equals 49. So we want to know what squared is 49. So what we're going to do is we're going to square root both sides. So this is what it would look like if we were showing all of our steps. We would square root this side and we would square root this side. Now, just a reminder, square roots can have a positive square root and a negative square root, and when we're doing this we actually want both. And remember from that exercise we did before, where remember squaring and square rooting canceled each other out because they're inverse operations. So x is what's left, and it turns out to be plus or minus the square root of 49. Now, what is the square root of 49? The square root of 49 is 7. So our answer is actually plus or minus 7, or positive and negative 7, because 7 squared is 49 and negative 7 squared is 49. So when we solve these equations, we're always going to be getting two answers. We're going to get that positive square root and we're going to get that negative square root. All right, so this time what we want is, and I'm just going to go ahead and do it this way now, we want the positive and negative square root of 5, 8, 3, 2. Well, you may not have that memorized, so I'm going to go ahead and pull up the table. And if we take a look, 5, 8, 3, 2, the positive square root of that is 18. All right, so x is actually plus or minus 18, or positive 18 and negative 18. All right, this next one looks a little more scary because it's a fraction, but actually we're just going to have plus or minus the square root of the top over plus or minus the square root of the bottom, which actually just turns out to be 1 plus and 1 minus. Okay, the square root of 81, do you guys know what that is? That would be 9. All right, and the square root of 225, I believe that is what, 15? We could check right here on our handy dandy table. Go to our square root, 225. The square root is indeed 15. So there we go. All right, plus or minus 9/15. Now remember though, when you get a fraction answer, you should see if you can simplify it. Is there a common factor that goes into 9/15? Actually, the greatest common factor will be 3, and that's going to simplify to 3/5, because 9 is 3 times 3, and 15 is 3 times 5. So we're factoring out that common factor of 3. and we get 3/5. So x is plus or minus 3/5. That's the answer that we are looking for this problem right here. All right, 676. Again, what are we looking for? All right, we're looking for plus or minus the square root of 676. If you don't know, go ahead and take a look. 676. There it is, 26. So x is plus or minus 26. See how easy this is? So 26 squared is 676, and negative 26 squared. Again, I just want to emphasize every time we're getting two answers because we have the positive root and the negative root, and we're looking for everything that makes it true, and that's both the positive and the negative square root. All right, back to a fraction. All right, so we're going to have plus or minus the square root of 144 over plus or minus the square root of 256. All right, so when we do that, we get x is plus or minus, well, the square root of 144 is 12. And let's see the square root. Whoops, I wanted just the plus or minus out in front. 12 over 256. Well, let's see here. If we don't remember, 256, go away, close window. That's right, I didn't mean to close that window. Darn it, 256. Well, let's open this window again, shall we? All right, perfect squares and roots. Here we go. Sorry about that little mistake here. All right, it happens. 256. There it is, 16 is that root that we're looking for. But again, 12 over 16 can be simplified, right? All right, so 12 and 16 are both divisible by 4, right? 12 is 4 times 3. 16 is 4 times 4. If we cancel that common factor of 4, we get 3/4 plus or minus. So the answer is plus or minus 3/4. By the way, I would not be a good math teacher if I didn't tell you that you can actually try to simplify these ahead of time, right? Okay, so if you had 144 over 256 before you square rooted, you could go ahead and simplify that, and you could say, well, what number goes into both 144 and 256, and you can simplify it, and then you could take the square root. All right, and it turns out that you could divide both of those by 16, and when you did that, you would simplify it, and you would get 9/16. All right, that's what it simplifies to, and then guess what? When you square root 9/16, you get that 3/4. So you can simplify before you solve, or you can solve and then simplify. Okay, all right, so that's how you do quadratic equations in one step. You take the square root. What about cubic equations? Well, like I said earlier, we're going to take the cube root, but there's a big difference with cube roots. All right, positive numbers have positive cube roots, and negative numbers have negative cube roots. There's only one root per number. All right, so when I solve this, x is going to be the cube root of 729. Notice there's no plus or minus going on. All right, so again, if I go to my list and now I look for 729, remember now I'm in that third column for cube roots. It's 9. All right, so x is simply 9, just positive 9, because if I put negative 9 there, I'd get a negative answer, and I don't have a negative answer. On this one, I do have a negative answer. So for this one, x is going to be the cube root of negative 4,096. So I know I'm going to get a negative answer. I head back to my table. I'm looking for 4,096. There it is. 16 is the cube root, but since it was negative, it's negative 16. All right, back to a fraction. So again, I'm going to take the cube root of the top, 1728, and I'm going to take the cube root of the bottom, 4913. All right, so you probably don't have those ones memorized. Those are pretty good, pretty big, I mean. 1728 is 12, and let's see, 4913 is 17. So x is 12 over 17. And guess what? 12 over 17 does not simplify. 17 is a prime number. It's only divisible by 1 and itself. All right, what about the cube root? Whoa, let's try this again. X is equal to the cube root of negative 512. All right, so we know it's going to be negative 512. Let's see where 512 is. 8. 8 is the cube root of that, but remember, since we were taking the cube root of a negative number, we get a negative answer. All right, and finally, 1,000 over 5,832 negative, so x is going to be the cube root of each of those. The cube root of negative 1,000 over the cube root of 5,832. You'll notice I put the negative on the 1,000. All right, when you have one negative, it can go on the top, the bottom, or out front. Okay, well, I'm just about out of space here, so I'm going to do it below it. So the cube root of 1,000, what is that? 10 times 10 times 10, isn't it? Cube root of 1,000 is 10. So on the top, I get negative 10. And 5,832, what about 5,832? That is 18. So I get negative 10 over 18. Those are the cube roots. But hey, those are both divisible by 2, right? So 10 is 2 times 5. 18 is 2 times 9. If I cancel that common factor of 2, I get negative 5 over 9. So that's the answer to that one. Negative 5/9. All right, there it is. Just a reminder, if we wanted to simplify that first, all right, we could have divided both of those by a number that goes into both of them. All right, I believe 4 would go into both of them, maybe even 8. We could do that. All right, but since they're both perfect cubes, I just like going with the table and then simplifying. I tend to like to simplify when I'm done rather than when I start, because especially for numbers like this, I got to try to figure out what that common factor is. Well, it's a lot easier to find a common factor of smaller numbers. All right. Okay, so ladies and gentlemen, boys and girls, that is how we solve one-step quadratic and cubic equations. Again, quadratic equations with that squared, we solve by taking the square root, remembering to take the positive and the negative square root. And cubic equations, we solve by taking the cube root. And in those cases, a positive cube has a positive cube root, and a negative cubic number has a negative cubic root. And that is all I have for you until next time.